Welcome back, Algebra 1 students. We are continuing our lesson over chapter 5.1. Last lesson we talked about how to graph an absolute value function, and then we also went over the learning target. I can analyze the graph of an absolute value function, so we're continuing to talk about that learning target today. So last lesson we talked about some success criteria. I'm just going to abbreviate it SC, success criteria. And to analyze this graph, you need to find the domain, the range, the vertex, and then finally the axis of symmetry. And we talked about that in the last lesson. We are going to continue to discuss that today, and we're going to add one more topic to analyzing the graph, and that's going to be finding the rate of change. And that's what we will be discussing primarily today. All right. So at this time, we're going to start here at number 7. It says, Jay rides in a boat from his home to his friend's home in a neighboring state. The graph of the function, given by this equation here, shows the distance of the boat in miles from the state line at t hours. So D standing representing distance and t representing time. Assume the graph shows Jay's entire trip. So what we're looking at here is Jeff's starting point, or Jay's starting point up here, and he's going to take a boat ride down to the border here, and then this increasing line here shows his distance after the border. Okay, so to the border and then away from the border. So the first question is, how far does Jay travel to visit his friend? So what I want you to do at this time is pause the video and answer these two questions here, A and B. All right, so how far does Jay travel to visit his friend? Well, if he starts here and he's traveling this far, here's the distance from 0 to this point right here would be 45. Okay, and then from here up to here, that's the same point right here, that's another 45. So 45 plus 45 gives you 90 miles. All right, and then how does the graph relate to the domain and range? So domain and range is something we talked about yesterday. It's the first 2 points of our success criteria over here. So I'm gonna call domain D and range R. So when you're finding the domain, we talked about domain is all the X values. And here would be the X values. Here's our X axis right here. So it's all the X values starting at 0, going through here. T standing for time. So our X values are the time. So the domain would be the time given on the graph. And then the range is all the Y values. Here's our Y axis right here. So the range, the Y values, is talking about distance in miles. And then we give domain and range in interval notation. So let's go back to the graph and find that interval. So for time, you're looking from left to right, from lowest to highest on the X. So the lowest point of the graph of the X right here would be at 0. Starts at 0. and it's going all the way to the end of the graph here. At this point, which if we were to continue to write those numbers, that would be 3 hours. So this graph shows from 0 to 3 hours, and that would be our domain. Let's look at the range, the distance. So you're looking at the y values lowest to highest. So the lowest point down here, here's the lowest point of the graph, and the y value at that point is 0. And then up to the highest point of the graph, which stops here at 45. So lowest to highest is 0 to 45 for the range. All right. Now we're going to go on to rate of change. This is the new part that we didn't talk about yesterday. Rate of change is another way of finding the slope. So you might have heard slope and rate of change used as the same meaning. So let's look at C. What is the range of change over the interval t from t here, t meaning time. So look up here, time is the same as x. Time is the x values. So 2 less than or equal to t less than or equal to 2.5. So we're looking from 2 to 2.5 right here. So here would be 2 to 2.5. So we're looking at this piece of the graph right here. So what is the slope, or what is the range of rate of change for that piece of the graph? So if t stands for time, and time is the x values, that means that 2 and 2.5 are x values. So our 2 would be our first x value, and our 2.5 would be our second x value. So to find the rate of change, you're going to use the slope formula. And the slope formula looks like this. M equals y sub 1 minus y sub 2, so y's go on top, and x's go on bottom. And you can flip those around too. This can say y2 minus y1, x2 minus x1, as long as they're consistent here. All right, so now we need to find our y values. We have our x values, we have our x1 and our x2. Now we need to find those y values. So this is how I'm going to do it. I'm going to start with my first x value of 2 right here. I'm going to go up until I hit the graph. And then that's the point where I'm going to turn and find what the y value is at that point. And the y value is right here at 15. So for my point here, that's going to be 2, 15. All right. So this is my x sub 1, and this is my y sub 1. Now I need to find the other y. So I'm going to use my second x here, 2.5. Now I need to find that second y. So let's go back to the graph. 2.5, hit the graph, turn to 30. All right, now we just need to take these values and plug them in to our formula. So y sub 1 is 15 minus y sub 2, which is 30. X sub 1 is 2 minus 2.5. And then we're going to solve from there. So this is going to be negative 15 over negative 0.5. then you would divide that, and that ends up being 30. So the rate of change is 30. So its rate of change is going 30 there. All right, so let's fill in our success criteria. So for rate of change, you're going to start with the given x values. In our problem, our given x values were right here, 2 and 2.5. And then you're going to use the graph. Here's our graph up here. Use the graph to find the y values. So how did we do that? We took our given value, 2, went up to the graph, went up until we hit the point on the graph, turned, and we found the y value. Again here, 2.5. Use your given value, now use the graph up until you hit it. As soon as you hit it, you turn, and you found that your y value was 30 there. Then after you find those points, right here, you got all your x and y values, then you plug it into your slope formula here. All right, so that's the last step. Ooh, ran out of room. Then use slope formula. All right, here's another one. It says, a cyclist competing in a race rides past a water station. The graph of the function, right here, shows her distance from the water station at t minutes. Okay, so here's your graph given there. It says, assume the graph represents the entire race. So this is the entire race from start to finish. What does the graph tell you about her race? Okay, so she's starting here, and then this point right here represents the water station. So right here, so she's cycling to that water station. And then after the water station, she goes and finishes the race. So she's going towards the water station. Now she's going away from the water station to finish up the race. So what can we learn from this graph? Well, I can see that it's decreasing here, and then as soon as she gets to that water station, it starts increasing. What can we know about the race? Well, she's starting at 0 minutes, and it takes her, let's see, it's going up by 15, so this would be 120. Takes her 120 minutes to finish the race. So from 0 to 120 complete minutes, so 2 hours. And then I can see the distance of the race. So from here to here, that's 20 kilometers. So it takes her 20 kilometers to get to the water station, and then another 20 kilometers to finish the race. So let's just put that all together as a neat sentence. What do we know about this race? Well, 20 plus 20 is 40 kilometers total for the race. And it took 120 minutes. So 40 kilometers total in 120 minutes. Okay, so that's the total. And then if we're just talking about the water station, it was 20 miles to the water station. And then that took, right here, 60 minutes. All right, so let's look at some other things. Let's analyze it. Let's find the domain, the range, the vertex, and the axis of symmetry. This will be a good review from last lesson. So the domain, you go left to right, looking at the x values, which in this case is time. So 0 to 120. Range is the y value, so in this case it's going to be the distance in kilometers. So the bottom of the graph is here at 0. And the top of the graph is up here at 20. Vertex would be this point right here. Vertex is that turning point, that sharp point of the graph. So that would be at 60 is the x value there. And then the y value is 0. And then the axis of symmetry is right here. And that is x equals, remember you take that x value of your vertex, so x equals 60. All right, let's move on. All right, we already talked about domain and range. Let's go answer this rate of change. So we will still need that graph here. Okay. Oh, that's the wrong paper. All right, there it is. Okay. Okay. So here's your x values. Remember t, time is the x values. So this is your x1 and x2. Then you have to find your y values. So you're going to use the graph to do that. So start at 15, turn 15. So there's your first point. Now we're going to use the second x value, which is 45. Up to the graph. As soon as you hit it, you turn and you end up at 5. All right, then you put that in your slope formula. So this is your x1, y1, and your x2, y2. You're just going to plug that in. And then simplify that down. So you get 10 over negative 30, which can reduce to negative 1/3. So we were looking from this point here, 15 to 45 on the x, so this piece right here. And if you notice, the graph is decreasing here. So that means I should get a negative slope. And I did. I got a negative 1/3. So let's check that. So you go down 1 and over 3. Down 1 and over 3. So you get negative 1/3. All right. All right, go ahead and try, go ahead, pause the video, try number 9 on your own. All right, let's check that one. So Kata gets on a moving walkway at the airport, then 8 seconds after she gets on, she taps Lisa. So here's Lisa right here. So here she is, she's going towards Lisa, taps Lisa. And now she's going away from Lisa. So coming towards Lisa, makes contact, and goes away from Lisa on this walkway. They want to know the domain and range. Domain is the x values, which in this case is the time. So it starts at 0. And then notice right here, this means it keeps going on forever. So to infinity. And then for the range, that would be the y values, which is right here, so that's your distance. So the bottom of the graph is at 0. And then the top of the graph, again, is going to keep going infinitely into the positive direction. Now we want to find the rate of change. Looking at the interval 0 to 8, t, remember, stands for time, which is our x values. So this is our x1 and x2. Now we need to find the y values. So we're going to use our graph to do that. So starting at 0 on x and going up until you hit the graph. So right there at the point 20. So 0, 20. And then let's find 8. That's our next value. And it's right there at 0. So 8, 0 is that point right there. So then we'll plug it into our formula. This is our x1, y1, x2, y2. Plug in the values, solve it, and reduce. -5/2 or -2.5. So that would be the rate of change. So what does this mean in terms of the situation? This means she's going at a rate of 2.5 feet per second. 2.5 feet per second. And that's going to be constant. It's a constant rate there. So that's going to be the same answer for C. And really, it should be the same answer. You should get 2.5 for this. Now let's look real quick. From 0 to 8, you notice that it's decreasing. It's decreasing, and that's why we got that negative slope. When we go from 8 to 16, this part, this is increasing, so we should get a positive slope. And it is constant, so we should get a positive 2.5 if we do it correctly. So let's check that. Those are my x values. I'm going to use my graph to find my y values. So it would be 8, 0. And then 16, 20. Then I'm going to plug it into my formula and solve. Simplify it down. Negative divided by a negative is a positive. And boom, got that 2.5, positive 2.5 at a rate of 2.5 feet per second. Okay, now it's your time to practice. Go ahead and pause the video and do page 9. Do page 9 at this time. All right, let's check this, see how you did. So quick review of the calculator here. To find absolute value, so I'm going to do -3. Absolute value, you go math, over, enter, and then put in your value, enter, and you get your answer. I'm going to go ahead and fill in this chart because you've already done this on your own. And then you would graph it. Okay, now we're ready to analyze it. The domain is from negative infinity to infinity. The range is from negative infinity up to the top at 0, y value 0 right here. Your vertex is this point right here where the graph turns from increasing to decreasing. That's at the point 0, 0. And then here's your axis of symmetry right here. Axis of symmetry is x equals, it's always this x value from the vertex, 0. Okay, then moving on to the next chart. I'm going to plug in all these numbers into your absolute value. Looks like this. Then you would graph it. Okay, domain, negative infinity to infinity. Range, 1 is the lowest point of the graph, and it keeps going on to positive infinity. Vertex is right here, this point right here, which would be 0, 1. And then here's your axis of symmetry, x equals 0. Moving on, next chart. Looks like this after you plug them all in. Graph it. Okay. And then your domain is negative infinity to infinity. Range, negative 5 to infinity. Here's your vertex right here at 0, negative 5. And then your axis of symmetry, again, x equals that point right there, 0. All right, next one. Fill in the chart. 1, 2, 3, 2, 1. Plot your points. Okay. Domain, negative infinity to infinity. Range, bottom to top, so going all the way down, negative infinity to 3. Vertex is right here at 0, 3. And then the axis of symmetry, x equals 0 there. All right, moving on to the bottom. Talking about rate of change. So this is what we just learned today. So here's your x-axis. So your x values is your time in seconds. Here's your y-axis. So your y values are your height. So domain is talking about time. Range is talking about height. So t stands for time. So that means that 3 and 6 are x values. So now we need to use these x values to find our y values here. So 3. So 3, 4 is this point right here. Now we're going to use 6 to find the other one. 6, 8 would be your other point. Plug it into your slope formula. So x1, y1, x2, y2. Plug in your values. solve it. So your rate of change is positive 3/4. And if you look, it's increasing here, which explains the positive rate of change. Increasing has a positive slope. All right, let's do the last one. Remember, these are x values. Use your x values to find your y values. So 7, 7, 7, and then 10, 3. 7, 7, and 10, 3. Plug them into your slope formula. And you get negative 4/3, which makes sense because we want that constant rate of change of 4/3, but right here it's decreasing, so that explains that negative. All right, hope you enjoyed this lesson.